Welcome back to today's class. In today's class, we are going to discuss about SAQs of mathematics to a complex number. From this chapter, you will get one SAQ for 4 marks. Our first question is, show that the points in the Argand diagram are represented by the complex number 2 plus 2i minus 2 minus 2i minus 2 root 3 plus 2 root 3i are the vertices of an equilateral triangle. So first write down the given A. 2 plus 2i we can write as 2 comma 2. B minus 2 minus 2i as minus 2 comma minus 2, and C minus 2 root 3 plus 2 root 3i as minus 2 root 3 comma 2 root 3. So these are the given 3 vertices of triangle. We have to show that these 3 vertices are vertices of an equilateral triangle. Means in equilateral triangle we have to show that distance between A and B, B and C and C and A are equal. Distance between all sides are equal. So what is this distance formula? Distance between 2 points A x1 y1 and B x2 y2 is AB equals to under root x2 minus x1 whole square plus y2 minus y1 whole square. Using this formula, first we have to find distance between A and B, then B and C, then C and A. If AB equals to BC equals to CA, then given 3 vertices are the 3 vertices form an equilateral triangle. So first find out AB. To find AB, write down A. What about A? That is 2 comma 2, and B minus 2 comma 2. Consider x1 y1 x2 y2. What about distance formula? Root over x2 minus x1 whole square. x2 means minus 2 minus x1 also 2, minus 2 minus 2 whole square, plus y2 means 2 minus y1 is y2 is minus 2. B is minus 2 now. So minus 2 whole square. So minus 2 is minus 4 whole square 16. Minus 2 is minus 4 whole square 16. 16 plus 16 is 32. Therefore distance of AB is root 32 units. Next we have to find distance of BC. Distance of BC. Distance between BC. So what about B? B is minus 2 comma minus 2, and what about C? C is minus 2 root 3 comma 2 root 3. Consider x1 y1 x2 y2. Now distance between BC, using the formula under root x2 minus x1 whole square y2 minus y1 whole square. x2 means minus 2 root 3 minus of minus plus 2 whole square. y2 means 2 root 3 minus of minus plus 2 whole square. So this is A minus B whole square, and this one is A plus B whole square. Yes, any relation is there between A plus B whole square and A minus B whole square? Yes, we know that A minus B whole square plus A plus B whole square is 2 times of A square plus B square. A minus B whole square plus A plus B whole square is 2 times of A square plus B square. Here A means, what about A? That is 2 root 2. Then A square is 2 2s are 4, root 3 square is 3. So 4 3s are 12. And what about B? B is 2. Then what about B square? 2 2s are 4. Therefore A square plus B square means 12 plus 4 16. Then our BC becomes, BC is root over 2 times of 16, or we can write 12 plus 4. And what about 12 plus 4? 16. So 2 into 16, that is root 32 units. So BC also root 32 units. And what about AB? AB also root 32 units. Next we have to find CA. So now distance between C and A. What C is minus 2 root 3 comma 2 root 3, and A is 2 comma 2. Now distance between CA, root over x2 means 2. Consider x1 y1 and this is x2 y2. Using the formula root over x2 minus x1 whole square plus y2 minus y1 whole square, 2 minus half minus plus 2 root 3 whole square plus 2 minus 2 root 3 whole square. This is also in the form of a plus b whole square and a minus b whole square, and formula of a plus b whole square and a minus b whole square is 2 times of a square plus b square. Same a here, 2 is there, so 2 square is 4, b is 2 root 3 like previous bc. So here also 2 times of 12 plus 4, that is 16. So 2 into 16 is 32, root 32 units. So here AB equals to BC equals to CA. Distance between AB and distance between BC and distance between CA are equal. Therefore, given 3 vertices form an equilateral triangle. Now next question is, if z equals to 3 minus 5i, then show that z cube minus 10z square plus 58z minus 136 equals to 0. Solution. First write on the given. Z equals to 3 minus 5i is given. This one we can write z minus 3 equals to minus 5i. Squaring on both sides, z minus 3 whole square equals to minus 5i whole square. So this is in the form of a minus b whole square. What about formula of a minus b whole square? A square plus b square, 3 3s are 9, minus 2ab, 6z equals to minus square is plus, 5 5s are 25, I square. But what about value of I square? That is minus 1. So this will becomes minus 25. So z square plus 9 minus 6z. From this one, if you make z square as subject, z square becomes minus 6z becomes plus 6z plus 9 minus 9. Minus 9 minus 25 is minus 34. Therefore, we have the value of z square is 6z minus 34. What about value of z square? 6z minus 34. Now, our LHS is z cube minus 10z square plus 58z minus 136. This z cube can be write as z into z square. Yes, z into z square is z cube minus 10z square plus 58z minus 136. Now substitute the value of z square. So what about z square? That is 6z minus 34 minus 10 times of, again value of z square is 6z minus 34 plus 58z minus 136. So if you multiply, z into 6z is 6z square minus 34z minus 10 6 are 60z minus of minus plus 340 plus 58z minus 136. So minus 60 plus 58 is minus 2 and this minus 34. So 6 times of, first I am writing again the value of z square is here. So what about the value of z square? That is 6z minus 34. So minus 34 and this minus 2, since minus 60 plus 58 is minus 2, becomes minus 36z, and 340 minus 136 is 204. 6 into 6, 36z minus 6 into 34 is minus 204. This minus 36z plus 204. So plus 204 minus 204 get cancelled, plus 36 minus 36 also get cancelled. Therefore, what remains? 0. Z cube minus 10z square plus 58z minus 136 equals to 0. Next question is, if x minus iy whole power 1 by 3 equals to a minus ib, then show that x by a plus y by b equals to 4 times of a square minus b square. First write on the given. X minus iy whole power 1 by 3 equals to a minus ib. So given is x minus iy whole power 1 by 3. So first cubing on both side. Cubing on both side. Then the given becomes x minus iy 1 by 3. After cubing 3 get cancelled, becomes a minus ib whole power 3. A minus ib whole power 3. This is in the form of a minus b whole cube. What formula of a minus b whole cube? A cube minus 3a square b plus 3ab square minus b cube. A cube minus 3a square b plus 3ab square minus b cube. If you expand using a minus b whole cube, first term is a, that is a cube minus 3 times of a square into b, but in the place of b, ib is there, so write down as it is ib, minus 3, next plus 3ab square, but in the place of b, ib is there, ib whole square minus b cube, that is ib whole cube. So first term a cube as it is. This one we can write minus 3a square b into I. Here I square is there, and what about value of I square? That is minus 1, and here I cube is there, value of I cube is minus I, so I square is minus, so plus becomes minus 3ab square, and value of I cube is minus I, so already minus is there, minus of minus plus ib cube. Now we have two real terms and two imaginary terms. So first write down the real terms, that is a cube minus 3ab square. Okay, now what are the imaginary terms? That is the terms containing I. So from these two terms, if you take minus I common, what remains? 3a square b. From this one, if you take minus I common, so minus b cube remains. Okay, now compare with x minus iy. Now equating both side real and imaginary parts. Equating real and imaginary parts. If you equate both side real and imaginary part, so first I am equating real part with real part. Okay, so x is a cube minus 3ab square. From this one we can take one a common. After taking a common, one more a square minus 3b square remains. From this one we can make x by a as a subject. Then what about x by a? That is a square minus 3b square. Value of x by a is a square minus 3b square. Now if you equate the imaginary parts, so what about imaginary part? That is minus I coefficient. So left side also minus I is there, right side also minus I is there. Now you equate coefficient of I on both sides, so y equals to 3a square b minus b cube. From these two terms we can take one b common, still 3a square minus b square is there. Now from this one, if you make y by b as a subject, then y by b value is 3a square minus b square. Now we have x by a value as well as y by b value. What about our LHS? So I am writing here our LHS. LHS is, we have to find the value of x by a plus y by b. What about value of x by a? That is a square minus 3b square plus value of y by b is 3a square minus b square. So if you add these two, a square plus 3a square is 4a square, minus 3b square minus b square is minus 4b square. From this we can take 4 common, so a square minus b square. So therefore x by a plus y by b is 4 times of a square minus b square. That is our RHS. Okay. Now next question is, if z equals to x plus iy and if the point P's in the Argand plane represent z, find the locus of z satisfying the equation mod z minus 2 minus 3i equals to 5. So first write on the given. What is given? Mod z minus 2 minus 3i equals to 5, where z equals to x plus iy. Now in the place of z we can write x plus iy. So first I am writing in the place of z, that is x plus iy minus 2 minus 3i equals to 5. So here two real terms are there and two imaginary terms are there. First I am writing the real terms. What are the real terms here? X and minus 2 are the real terms. So I am writing x minus 2. Okay. Now what are the imaginary terms? The terms which contain I are called imaginary terms. The coefficients of I are imaginary terms. So if you take I common, y minus 3, okay, equals to 5. So here mod is there. What is mod? If z is any complex number that is in the form of a plus ib. If z equals to a plus ib, then mod z equals to root over a square plus b square. If z equals to a plus ib, then mod z equals to a real term whole square plus imaginary term whole square. So what about real term here? X minus 2, and imaginary term, that is y minus 3. So using the property of mod z, this will becomes root over first term, that is real part x minus 2 whole square plus imaginary part y minus 3 whole square equals to 5. Now squaring on both sides, this will becomes x minus 2 whole square plus y minus 3 whole square equals to 5 square. So this is the equation of a circle in standard form whose center is 2, 3 and radius is 5. We can further expand this equation using a minus b whole square, that is x square, 2 2s are 4 minus 4x, a square plus b square minus 2ab plus y square, 3 3s are 9 minus 6y equals to 5 5s are 25. If you arrange in order, x square plus y square minus 4x minus 6y, 4 plus 9, 13 minus 25 is 13. Actually 13 minus 25 is 12. Okay, so this x square minus x square plus y square minus 4x minus 6y minus 12 equals to 0 represents a circle whose center is, what about center? That is 2, 3 and radius is 5. What about radius? Radius is 5. So the equation of locus of P represent a circle whose center is 2, 3 and radius is 5. Okay. Therefore locus of P is a circle with center. What about center of the circle? With center, okay, 2, 3 and radius r equals to 5. Now next question is, show that the 4 points in the Argand plane represented by the complex number 2 plus I, 4 plus 3i, 2 plus 5i, 3i are the vertices of a square. So first write on the given. So given a equals to 2 plus I, we can write 2 comma 1, b equals to 4 plus 3i, 4 comma 3, c equals to 2 plus 5i, that is 2 comma 5, and d equals to 3i. So here real part is not there, so 0 comma 3. We know that distance between a x1 y1 and b x2 y2 is ab equals to under root x2 minus x1 whole square plus y2 minus y1 whole square. So here first we have to find distance between ab. So a is 2 comma 1, b is 4 comma 3. Consider x1 y1, x2 y2. So what about distance formula? That is root over x2 minus x1 whole square. So we have to show that given vertices are the given vertices form a square. So in a square we know that all sides are equal, means we have to show that AB equals to BC equals to CD equals to DA or AD. AB equals to BC equals to CD equals to DA, as well as diagonals. What are the diagonals? That is AC equals to BD. If all sides are equal and diagonals also equal, given vertices form a square. So diagonals AC BD. Okay. So first find out AB, distance of AB using the formula x2 minus x1, that is 4 minus 2 whole square plus 3 minus 1 whole square. What about 4 minus 2? That is 2. 2 square is 4. 3 minus 1, 2 square is 4. 4 plus 4 is root 8. Next, distance of BC. So B is 4 comma 3. C is 2 comma 5. Consider x1 y1 x2 y2. Then BC becomes root over 2 minus 4 whole square, 5 minus 3 whole square. What about 2 minus 4? That is minus 2 whole square is 4. 5 minus 3, 2 square is 4. 4 plus 4, again root 8. Next, CD. C is 2 comma 5 and D is 0 comma 3. Then distance between C and D, CD equals to root over 0 minus 2 whole square, 3 minus 5 whole square. 0 minus 2 is minus 2 square is 4. 3 minus 5 minus 2 whole square is 4. So root 4 plus root 4 is root 8. Next we have to find DA. So D is 0 comma 3 and A is 2 comma 1. So distance between DA equals to x2 means 2 minus 0 whole square, y2 minus y1 means 1 minus 3 whole square. 2 minus 0 is 2, 2 square is 4, 1 minus 3 is minus 2, square is 4, is root 8. Therefore AB equals to BC equals to CD equals to DA. All sides are equal. Now what about diagonals? So diagonals AC. Okay, so A is 2 comma 1, C is 2 comma 5. So AC is 2 minus 2 whole square, 5 minus 1 whole square. 2 minus 2 is 0, 5 minus 4, 16, or root 16 we can write 4. And finally AC BD. So next diagonal is BD. B and D, distance between B and D. So B is 4 comma 3, D is 0 comma 3. So 0 minus 4 whole square and 3 minus 3 whole square. What about 0 minus 4? 4 square is 16. 3 minus 3 is 0. So root 16 is 4. Okay, therefore AC equals to BD. All sides are equal and diagonals also equal. Therefore given vertices are form a square. Now next question is, show that the points in the argand plane represented by the complex number minus 2 plus 7i, minus 3 by 2 plus 1 by 2i, 4 minus 3i, 7 by 2 into 1 plus I are the vertices of rhombus. So here 4 vertices are given. We have to show that the given vertices form a rhombus. In a rhombus there are 2 conditions are there. First condition is all sides, that is AB equals to BC equals to CD equals to DA. All sides are equal. And second one, diagonals, that is AC equals to BD. We have to show that all sides are equal and diagonals also equal. All sides as well as diagonals are equal, then the given 4 points form a rhombus. So we have to find distance of AB, BC, CD, DA as well as AC, BD. So first find out distance between AB. So what was distance formula? Under root x2 minus x1 whole square plus y2 minus y1 whole square. So first term A, that is minus 2 comma 7, and B is minus 3 by 2 comma 1 by 2. Consider x1 y1 x2 y2. What about formula of distance between AB? Root over x2 minus x1. x2 means minus 3 by 2 minus of minus plus 2 whole square plus y2 means 1 by 2 minus 7 whole square. So this will becomes root over 2 2s are 4, cross multiply, 2 2s are 4, 4 minus 3 is 1 by 2 whole square, and this one 2 7s are 14, 1 minus 14 minus 13 by 2 whole square. So 1 by 2 2s are 4, 13 square 169 minus 13 whole square also plus 169 divided by 4, that is root over 170 by 4. So value of AB equals to root over 170 by 4. Next, value of BC. So distance between B and C. So what would be? That is minus 3 by 2 comma 1 by 2, and C is 4 comma minus 3. So x1 y1 x2 y2. So distance formula BC under root x2 minus x1. x2 means 4 minus of minus plus 3 by 2 whole square, y2 minus y1, that is minus 3 minus 1 by 2 whole square. So this will we can write further as 2 4s are, what about 2 4s are? 8 plus 3 11, that is 121. 11 square is 121 by 2 2s are 4. Now 2 3s are minus 6 minus 1 minus 7. Minus 7 whole square is 49 divided by 2 2s are 4. So 121 plus 49 is 170 divided by 4. So AB equals to BC. Now next CD. C is x1 y1, D is x2 y2. So using the formula under root x2 minus x1 whole square, y2 minus y1 whole square, that is 7 by 2 minus 4 whole square plus 7 by 2 minus of minus plus 3 whole square. So if you cross multiply, 2 4s are 8, 7 minus 8, that is minus 1 by 2 whole square. 1 by 2 whole square is 1 by 4 plus 2 3s are 6, 6 plus 7 13, 13 square is 169 by 4. 1 by 4 plus 169 by 4, 170 by 4. Next, DA. So D x1 y1 x2 y2. So minus 2 minus 7 by 2 whole square plus 7 minus 7 by 2 whole square. So this will becomes 2 2s are minus 4 minus 7 minus 11 whole square is 121 by 4, and 2 7s are 14. 14 minus 7 is 7. 7 square is 49 divided by 4. This will becomes 170 divided by 4. Therefore we got AB equals to BC equals to CD equals to DA. AB equals to BC equals to CD equals to DA. All are equal, that equals to 170 by 4. Okay, next we have to find diagonals. What are the diagonals? That is AC and BD. Diagonals AC and BD. So AC, so what about A? That is minus 2 comma 7. C is 4 comma minus 3. Then our AC is, using the formula, under root x2 minus x1, that is 4 minus half minus plus 2 whole square minus 3 minus 7 whole square, minus 3 minus 7. So 4 plus 2 6, 36. 6 square is, this is minus 10, 10 square is 100. So root 136. Okay, next what about CD? This is our AC. Next BD. So B is minus 3 by 2 comma 1 by 2, and D is 7 by 2 comma 7 by 2. Now distance between BD, under root x2, that is 7 by 2 minus half minus plus 3 by 2 whole square. 7 by 2 minus 1 by 2 whole square. 7 plus 3 is 10. 10 by 2 is 5. 5 square is 25. 7 minus 1 is 6. 6 by 2 is 3. 3 square is 9. That is root 34. Okay. So AC is not equals to BD. All sides are equal and diagonals are not equal. Therefore, given vertices form a rhombus.